All right, everyone. We are into notes 6.6. This is one of the bonus notes. You do not have to do this activity, but it will get you extra credit. And I think it's a pretty cool extension of some of the trigonometry that we've been doing. So far, everything we have done in trigonometry has been about what kind of triangles? Right triangles. Hopefully you haven't tried to use any of the trigonometry on non-right triangles. But if you wanted to, now is the time, because the law of sines is a formula we can use for all triangles, which is pretty exciting if you ask me. So what is the law of sines? It can be written two ways. Either sine of A divided by A equals sine of B divided by B. In other words, the ratio, oops, and this is actually a mistake I've made, so erase this. These A and B's represent the sides, so they should be lowercase, A and B, or it can be written just flipped, A divided by the sine of A equals B divided by the sine of B. This is for any sides in a right triangle. Of course, A and little a and big A have to be opposite sides. So what this is saying is that the sine of this angle B divided by this side B is equal to the sine of angle A divided by this side A. And it works for side C too. There's no reason you can't do C. In fact, I will include that here as well. Sine of C divided by C, or C divided by sine of C. You can use it either way, whichever way is easier, or you can switch back and forth. It doesn't matter if the side's on top or the angle or the sine of the angle is on top. It just matters that you're consistent. So if the little a is on top, little b needs to be on top, little c needs to be on top. And the law of sines is really useful because it helps us find missing sides and angles of a triangle. And we can use it for non-right triangles, which is pretty cool. To use it, we either need one side and two angles, or we need two sides and an opposite angle. If we have two sides, we need the angle we have to be opposite one of those two sides. And we're going to go ahead and see an example in just a second, but first a reminder, this is going to be super useful as we move through this. Angles in a triangle always need to add up to 180 degrees. This means that if we have two angles, we can always figure out the third by just thinking, what number do we need to get to 180 degrees? And we're going to see how that's useful in just a second. Okay, example number one. I accidentally went too far. Here we are. Finding a missing side. Okay, first things first, we are going to write the law of sines. Let's do this. We will, in this case, put the sides on top. A divided by sine A equals B divided by sine B. So I'm really not good at writing with my mouse, so I apologize for it being so messy. Then we're going to substitute in values from the triangle. So it's important to note this triangle is labeled ABC. It doesn't matter what is labeled, as long as little a matches up with the side across from it. So I could call this X or Y or whatever. It just matters that these two match up when we put them into the formula. Now we have little a, it's 16. Right over here. But what is sine of A? Now this is where we can use the fact that we know that triangles, the angles in a triangle add up to 180. So we've got 80 plus 34 plus A equals 180. So we just have to solve this equation to figure out what A has to be. You can do that on your calculator. I believe it is 66 degrees. So now we know angle A is 66 degrees. We can plug that in here. Sine of 66. Sine of B is 34. So this is going to be sine of 34. And we're trying to figure out what B is. All right. Well, this is actually not too bad. We're just going to do a little bit of math on the calculator. So get out your calculator. Put in 16 divided by sine of 66 degrees. And I will do that as you do. And I got 17.51. So 17.51 equals B divided by, now put in sine of B on the calculator, sine of 34 degrees. And I got 0.55919. Again, as many decimals as you can include, the more accurate your answer is going to be at the end. It's better not to round at all until you get to the end. So now we just multiply that by 17.51 to cancel this out because we're dividing by 0.55. So we do times 0.55919. Got to do the same thing on both sides. 0.599. Wow, writing all of these is going to kill me. And I actually didn't even write it correctly. There's only 1 9. Oh my goodness. What am I doing? I could just re-record this video, but I'm not going to because I am lazy. Okay, now we do that multiplication. We press enter on our calculator. We get 9.79 equals B. There's our answer. 9.79 equals B. And I'll just type this, I guess. 9.79. Now, in a lot of these problems, I am asking you to find all of the missing sides and all of the missing angles of this triangle to solve the triangle completely. So we found this side, we already have one side, but we still need to find the last side. Now we can do that again by just using the law of sines again. So this time we're going to use it with C. We've got C equals, we'll use A again, why not? And it's going to be divided by sine of C. What's the angle that goes with C? 80. And that's going to be divided by sine of what's the angle that goes with A? 66. So C divided by sine of 80 equals A divided by sine of 66. So 80 matches with this side over here. That's what we're trying to figure out. This is C. A, we already know. We can cross that out and make it 16 because that matches with this. So same thing we did before. 16 divided by sine of 66. Doing this on my calculator as we make the video so that you see how it's done. Sine of 66 degrees, 16. And this is going to be equal to 17.51. I actually didn't need to do that because we had already done this before, right? We had done it up here. But I do need to find the sine of 80 degrees because we haven't done that before. The sine of 80 degrees is 0.9848. 0.9848 divided by C. We need to cancel this out, so we're going to times by it on both sides. And that's going to give us that C equals that times 17.51, which equals 17.24. So that tells us that this side C is 17.24, which seems about right. This is the longest side. It's bigger than 16, but not by that much. So 17.24, 9.79, 16, and we have all three angles. So we have solved this triangle. We'll go ahead and look at one other example on the back side of these notes. Okay, I went too far again. All right, same thing as before. We're going to use our law of sines. This time, because we don't have the sides, we're going to do the same thing. So we need to find the missing side, and we'll fill in this angle first so that we have it. 95 and 30 is 125, so this will have to be 55 degrees. All right, now we've got all the angles. We're going to substitute values from the triangle we are given. So wait, we're going to write down the law of sines first. Sine of A equals sine of B, sine of C. And this is all divided by A, B, and C. Okay, so let's have A be R, because that's what we've got so far, which means R is big A. Again, all that matters is whatever you choose, they have to match. They have to be opposite. So we've got 8 divided by sine of 30 degrees. That's going to equal B. Let's have B, I don't know, BS, which means big S is big B. So we'll have B divided by sine of 55. And that leaves C to be T. This is big C, little c, C divided by sine of 95. Okay, and then again, we're just solving. So what is 8 divided by the sine of 30 degrees? Well, that is going to be 8 divided by 0.5, which is 16. So 16 equals B divided by the sine of 55, which means we need to do times the sine of 55 on both sides. So 16 times sine of 55 degrees. This is something you can put into your calculator all at once. You don't need to find the decimal first. You can just do times sine 55. Kind of a shortcut. That way you don't have to worry about rounding at all until you get to the end. That's going to cancel out this, leave us with just B. And it's going to tell us that this is 13.1 about. And this is B, which was S, so this side is 13.1. Now we'll do the same thing with C, sine of 95. So we have 16 equals C divided by the sine of 95. Multiply both sides by the sine of 95. And this is going to cancel out. And we're left with C equals 16 times the sine of 95. We will do that again on the calculator. And it should be a number that's the biggest we've gotten so far, 15.93. 15.9, actually 94 if we round it. So this will be 15.94. Okay, we've got all of the sides. We've got all of the angles. We have solved this triangle. Now you're going to do that for your practice. Good luck, and let me know if you have any questions.